Hi, this is Math 2510, and this video is part 2 of section 6.3. And we're going to finish up what we were looking at before and then get into washers, and that'll be the end of this section. What we were doing before, we were rotating a function about the x-axis. And using disk, we would find the value. Now we're going to rotate this function about the y-axis and using disk find the value. So the idea is very much the same. You're using a disk, so your area is going to be pi r squared, and the function for the radius is going to be, your function. The difference is we have to bring this out in around the y-axis, so we're going to use y instead of x's. And so a volume is going to be written from C to D, which is going to be limits along your y-axis, and then pi f of y squared dy. Right, so if we're looking at y equals x squared and up to y equals 4, so 1, 2, 3, 4, x squared would be 0, and 1 squared is 1, 2 squared is 4. So we're looking at this, and then we're going about the y-axis, so it ends up being the same on this side. And then we're using this cross-sectional area that's now basically horizontal. So our radius goes from the axis to f of y. And so we'll solve this for x. So x is square root of y. So we can rewrite this volume as integral pi square root of y squared dy. And along the y's, we are adding these horizontal disks up from 0 to 4. Give me 1 second. I'm going to plug in my computer. But so make sure it's charging. Okay, it is. All right. So now we're going to integrate this. Actually, let's simplify this first. So 0 to 4 pi y, when the square root of y squared is y, dy. And so when we integrate this, we get pi y squared over 2 from 0 to 4. And so we'll get 16 pi over 2, which is going to be 8 pi, which is about, let's see, 25.13. Right, next one, y minus 3 squared. And we're going to look at it from 0 to 3. So when x is 0, we get negative 3 squared, which is 9. So we'll just, see, 3, 6, 9, we'll call that 9. And then when x is 3, we get 0. 1, 2, 3. X is 1, we get negative 2 squared is 4. somewhere around here. And when x is 2, we get -1 squared, which is 1, so somewhere down here. So it's just kind of shape here. And we're again going around the y-axis. It looks kind of like a tent in a way. Or hat, which is hat. And then we're going to solve this for x. So it'll be square root of y equals x minus 3. So x equals 3 plus square root of y. And so the volume is going to be integrated from 0 to 9 of pi 3 plus square root of y squared dy. We'll have 0 to 9 pi. Let's see, 3 times 3 will be 9 plus 6 square root of y plus y dy. And we can integrate each one of those. So we'll have pi 9y, and then this will be to the 3 halves. We'll divide by 3 halves, which is the same as multiplying by 2/3. So we'll have 6 times 2 over 3, which would be 4, plus y squared over 2, integrated from 0 to 9. So 0 is going to make all that 0. We'll have pi, when we plug in 9, we'll get 81. Plus, let's see, 4 times square root of 9 is 3, and 3 cubed is 27. 81 over 2. So pi, let's see, 4 times 27. This is 108 plus 81. 189 plus 81 over 2. 229.5. There's about 720.996. Alright, so the last two problems we'll have before we get to washers looks at not just going about a y-axis or x-axis, but an axis parallel to one of those. Right, so in this case, we're going to look at x equals 3. And that's the axis we're going to send about a function. We'll look at y equals x. It's a line like this. And we're going to look at it from 0 to 3, so I can get rid of this section of it. And we're going to rotate this around. So you get kind of like a hint here. Alright, so now we have to figure out what the radius is. Right, so our volume is going to go from 0 to 3 pi, and we got to get our radius, which is going to be squared. Now, a radius will go from basically here to here. Okay. This is the function minus 3. Okay, because you got x equals 3. The function itself is x. So x minus 3. Oh, I'm sorry, we gotta be in the y's though. So then I don't want to put that in here. We're gonna be in the y's because we gotta go from around our x-axis or parallel to our y-axis, our x equals 3. So we gotta have this. So our radius is still the same as y equals x minus 3. We just gotta solve this for x, for y plus 3. So that goes from the function around and bringing this around x equals 3. Our limits still go from 0 to 3 because that's where the y-axis will go. Right, so we'll integrate this. Well, we'll simplify this first. 0 to 3 pi y squared plus 6y plus 9 dy. And so we'll take the antiderivative. Pi y cubed over 3 plus 3y squared plus 9y from 0 to 3. Zeros won't matter. So the bottom limit doesn't matter. So you get pi 3 cubed is 27 over 3 plus 3 cubed is 27 plus 27. And so we'll have that's 9 of 5463 pi. 197.92. For the volume generated by rotating y equals x cubed about line equals x equals 2. That's going to be here. X cubed. We'll go do this from 0 to 2. So we'll do 0. 1 cubed is 1. 2 cubed is 8. Here. So this line across onto this side gives you this kind of tall cone. Again, we'll do this with y's. So we'll go from 0 to 2, or 0 to 8, all the way up to 8. Pi. And then this is going to be the cube root of y equals x. We are at y cubed squared dy. Right, so we can take the antiderivative of this. So that would be, we have 2/3, so we add 3, so it would be 5/3. Pi is on the outside, and then we're dividing by 5/3, which is multiplying by 3/5. 0, 8. Again, 0 is going to make it 0 and for the lower limit, so 3/5 pi 8 to the 5/3. That'd be 3/5 pi to the 5th power. Which is 32. 3 times 32 over 5 pi, which that'll be 96 pi over 5 pi, which is going to be 19.2 pi, about 60.332. All right, so that is the volume for rotating it over the x equals 2 line. Actually, I made a mistake. I did this as in if we're rotating over the y-axis. We are rotating this over x equals 2. We didn't do the radius right. So radius here, you have to subtract 2 from. I did not do that. Wondering why it seems so much easier. Let me go through this. I didn't notice it before I moved on. So a radius. We are going from 2 to x equals 1/3. So we are subtracting 2 from y equals 1/3, or y to the 1/3 dy. And that's gravity squared. We still have to square this out then. A y to 2/3 minus 4y to the 1/3. That'd be 2 of those. And then plus 4 dy. There would just be more involved in this, but it's not going to be too bad. So we'll take the antiderivative, y to the 5/3 times 3/5 minus 4y to the 4/3 times 3/4, so the 4 actually cancels, and then plus 4y, 0 to 8. And so we'll plug in 8. Zero is going to make everything 0, so we don't have to worry about that. So we'll have 3 times 32 over 5. On that side, we'll have 2 to the 4th 16, so we'll have 48, 32. So that'll be, let's see, 19.2 minus 48 plus 32. Will give me 3.2 pi. It's about 8.7. Don't check my math yet. All right. Now the next part of this is washers. Washers are when we are rotating it where it's not right up against the axis of rotation, and so it creates a hole. Right, and we see the little region separated from that line, and so when we rotate this around, you end up with what looks like a toilet paper roll, where there's a hole going between it. And so um, we'll rotate it in such a way that we have a hole. And so if we look at the cross-section area, it looks like a washer, the tool, circular ring. And so the area of this cross-section is pi times the outer radius, or minus pi times the inner radius. We can call this f of x. We can call this 1 g of x. F of x is our outer radius or outer function. G of x is our inner function. And so we can write this as pi f of x squared minus g squared dx. All right, so when we integrate this, we're integrating it with x's. We'll have integral from a to b, pi f of x squared minus g of x squared dx. If we're integrating it from the y aspect, our limits have to go from c to d, so that's along the y-axis. I'll have pi still, but we're going to do p of y squared minus g squared, or not g, q squared of y. Basically, you just gotta remember that you gotta make your function in terms of y. The outer one, or the one that's that would be farther away from the origin, it's going to be the one that gets uh, that goes first. And so you subtract whatever's closest to the origin. All right, so let's say we are looking at y equals x squared and y equals x. So I'm going to draw this out where 1 is over here. So 1/4, 1/2, 3/4, 0. Because we're going to do this between 0 and 1. Because that's what they end up equaling. So 0, 0, both have that point common. 1, 1. This way too. 1's up here. 1 is going to be up here. Because they both end up equaling, but they don't fall along the same line. The y equals x is pretty straight. Whereas if we were to look at 1/2, for instance, 1/2 squared is 1/4. That's what that is. 3/4 squared is 9/16, which is just after 1/2. About somewhere along here. So it looks like this. We have this little region there where they're not the same. And that's going to be rotated onto the other side. Creating this kind of volume where that center piece is being taken out. So If it used to look like a loudspeaker before, now it really looks like a loudspeaker because you got the inward part of this. That's not there anymore. You have a hole there. Right, so the way we do this, volume equals integral from 0 to 1. This is going to be along the x-axis. It wouldn't matter in this case, but we're going to do it along the x-axis. The y equals x, that's the outer one. So we'll have pi x squared. And y equals x squared is the inner one. So minus x to the fourth dx. So we'll integrate each of these. So pi x cubed over 3 minus x to the fifth over 5. And that'll be integrated from 0 to 1. 0 is not going to matter in this case. It's going to make everything 0. So we'll have pi 1/3 minus 1/5. 1/3's higher and you get a positive number. That's kind of what you really want. We'll find common denominator here though. 5/15 minus 3/15 give us 2 pi over 15, which ends up being 0.46. That ends up being the volume there. Okay. Now we want to find the volume generated by rotating about the y-axis, the region bounded by y equals x squared and y equals square root of x. And again from 0 to 1. So 0, make this 1. We'll bump these up by 4s. So make that 1. So 0, 0 is both 1. So we're looking at 1/2 squared, we get 1/4. So that's that piece to this. If we're looking at square root of 1/2, we get about 7.707. So that's just higher, just below 3/4. So they both have kind of this bend to it. The biggest thing is realizing which one's the outer one. So the volume now will equal from 0 to 1 pi. The outer radius is your x squared, square root of x. So when you square that, you get just x. Minus the inner radius is your x squared. So when you square that, you get x to the 4th dx. So we'll integrate this. You get pi x squared over 2 minus x to the 5th over 5. Integrate from 0 to 1. Again, 0 won't matter here. So we'll put in 1 pi 1/2 minus 1/5, which is 0.5 minus 0.2, which is 0.3. So you get 0.3 pi, which comes out to be 0.942. These are not the same at all because, well, you're not dealing with the same functions, even though they're kind of around the same space. Alright, so now we want to find the volume. I'm going to make sure this is still recording. Okay. Find the volume generated by rotating the line y equals 3, bounded by sine of x plus 1, and y equals 1, x equals 0, and x equals pi. Right, so we're still going to use washers for this. Let me kind of draw this out though. what we're going to do is the x-axis, we're going to do this as 0, pi over 2, and pi. Okay. And 0, plug that into sine of x, you get 1. This is going to be 1, 2, 3, and 4, and 5. So 0, you get 1. If you plug in pi over 2, you get 0, so you get 1 plus 1 is 2. And then pi, you get 0 again, plus 1 is 1. This is your line. And then y equals 1, this line. And this is going to rotate about y equals 3. And so you have that hole in the center. It looks like the hourglass in the center there. And so we got to look at these radiuses. Let me throw this on the other side here. So your outer one is this one here. That's your outer radius. Inner radius goes to the function. So what we are looking at here is we have the outer one going from all the way from the axis of rotation down to y equals 1. That radius is 2. This is 3 minus 1. And this one is going to be a radius of 3 minus sine of x. So the inner one is 3 minus sine of x. Alright, so we can write this now. Biome equaling from 0 to pi, outer radius, which is 2 squared, so it would be 4, minus your inner radius, which would be 3 minus sine of x squared. Alright, sine of x plus 1. Yeah, not just sine of x plus 1. Squared dx. Alright, we have to square out sine of x plus 1 and then subtract it from 3. So when we square this out, here, we get sine squared x plus 2 sine x plus 1. So we'll write this out. 0 to pi, 4 minus 3 minus. And I'm going to subtract each of these so I don't have to distribute the negative sign again. So sine squared x minus 2 sine x minus 1 dx. And then we can put this together, 0 to pi or pi. Now let's distribute this negative sign as well. So this makes this negative, positive, positive, positive. So now we can put all that together. We'll have 4 minus 3 plus 1 gives 2. It's this, the negative 3 and the plus 1. Plus sine squared x plus 2 sine x dx. No, I didn't mean go back. I made it. I squared out the sine x plus 1. That's not what I'm supposed to square out. I just realized that. These are kind of off. I'm supposed to square out the 3 minus sine x plus 1. Easily mistake that I can make. Alright, so we're doing 3 minus sine of x plus 1 times 3 minus sine of x plus 1. So what we get here, we get 9, and then we'll get a negative 6 sine of x plus 1. You just got to treat the sine of x plus 1 as its own self, plus sine of x plus 1 squared. That's what we would end up having to square that out, which we'll do here soon. So we'll have 4 minus, and we'll subtract out each of these. So minus 9 plus 6 sine of x plus 1 minus sine of x plus 1 squared dx. And now we have to FOIL the sine of x plus 1 out. Right, so we'll have, and put some of this together. So negative 5 plus 6 sine of x plus minus plus 1. And then when we FOIL this out here, we'll get sine squared x plus 2 sine x plus 1. We'll have minus sine squared x minus 2 sine x minus 1 x. So now 0 to pi or pi. Negative 5, negative 1 gives us a negative 6. Then we'll have 6 sine x plus 6 minus sine x squared x minus 2 sine x. And we already took care of that 1. All right, so some of this can be put together. Negative 6 and the 6 cancel. Then you'll get a 4 here as you combine it with that. So we are at 0 to pi or pi. 4 sine x minus sine squared x. Now, we did this in a previous problem. The integral of sine squared x equals x over 2 minus sine 2x over 4. So we're going to have to do that as well. So we'll end up getting pi times a negative 4 cosine x and minus x over 2 plus sine of 2x over 4 integrated from 0 to pi. Now as we put this in, some of these will be 0, some will not. Let's see what is. So pi, cosine of pi is negative 1, so you get negative 4 times negative 4, so you get 4 out there. So it saves. Well, 4 minus pi over 2. And then we'll put in pi for the sine of 2x, you get 0. All right, so that we'll have that part of it. And minus, you put in 0 for cosine of x, you get 1, so you get -4 there. And then 0 for x over 2 is 0, sine of 0 is 0, so that'll be it there. We get pi, 4 plus 4 will be 8 minus pi over 2. And that will give you 20.2. Find the volume in the area contained between y equals x squared and y equals 2x. Very similar. We're going to do this about the x-axis, then we'll do this about the y-axis, and then we'll do this about y equals 4. All right, so first for the x-axis, I'm just going to draw it once. 0. Let's see, that's going to be 1 and 2. So 2 times 1 is 2. Do this 1, 2, 3, 4. 2 times 1 is 2. 2 times 2 is 4. And for x squared, 0, 0, 1, 1, 2, 4. Apply 1, 1 to the wrong spot. 1, 1, 2, 4. Goes like that. Alright, so the volume is from 0 to 2. Pi. The outer part is your 2x, so it'll be 2x squared, which would be 4x squared. Then x squared is the inner part, so it'll be x to the 4th dx. And so when we integrate this, we'll get pi 4x cubed over 3 minus x to the 5th over 5, 0 to 2. So it'll be pi 4 2 cubed over 3 minus 2 to the 5th over 5, 0. Make those both 0, so revert that limit. This becomes 32 over 3 minus 32 over 5. And we put this in a calculator, we get 13.4. Right, so we're going to do this about the y-axis. Same idea, we're going to use the same functions here. I'm going to go back up to this graph though. We're rotating around the y-axis. So your outer radius is actually your x squared there. So our volume will be from, we'll get the limits here in a minute. So you have pi x squared, which will be x to the 4th. Well, actually, hold on a second. We're doing it across the y, we have to use blocks. So we have x squared as the outer one. So that's going to be x equaling the square root of y. The square root of y squared minus, and then inner one's your 2x. So if we solve that for x, we get y over 2. So y squared over 4 be your inner function. And then we're doing this along the x-axis. And so we'll do this, or we'll take the limits along the y-axis. So we're doing this from 0 to 4 for your y. Those are your limits. So let's simplify this. Pi y minus y squared over 4. So we take the antiderivative, you get pi y squared over 2 minus y cubed over 12. Integrate from 0 to 4. 0 makes the whole thing 0, so we won't have to worry about that. We'll have 4 squared over 2 minus 4 cubed over 12. You have 16 over 2 minus 64 over 12. This would come out to be, let's see here, simplify this out. So I multiply this by 6. 16 by 6, get 96 over 12, minus 64 over 12. We'll have 32 over 12, which becomes 8 pi over 3, which becomes 8.38. Okay, so that's rotating it around the y-axis. Last one, we gotta rotate this around y equals 4. And so our, let's draw this out real quick. 1, 2, 1, 2, 3, 4. Y equals 4. 2 and 2. So we're rotating around this. So your inner radius is just going to be 4 minus 2x. And your outer radius is going to be 4 minus x squared. And we're doing this across the horizontal, so we'll use x's for this. And so our limit's going to go from 0 to 2. So pi 0 to 2, your outer radius, 4 minus x squared, minus the inner radius, which is going to be 4 minus 2x squared. So we will FOIL these out. So we will get 16 minus 8x squared plus x to the fourth minus 16 minus 8 be 16x plus 4x squared dx. Alright, so this becomes negative, positive, negative as we distribute the sign. 16 minus 16 cancels that out. So our volume is pi 0 to 2. Let's see, x to the fourth. I'm going to do this in order. Negative ax squared minus 4x squared is negative 12x squared. And then you have 16x dx. The volume is pi 0 to 2. Well, I don't want to write that out. I want to take the antiderivative. So x to the fifth over 5 minus 4x cubed plus 8x squared. Integrate from 0 to 2. Okay, 0 goes in, everything's 0, so we don't have to worry about the bottom limit. 2 to the 5th is 32, so it'll be 32 over 5. 2 to the 3rd is 8, so it'll be 32. 2 to the 4th, 2 squared is 4, so it'll be another 32. So these cancel out. You get 32 pi over 5, which comes out to be about 20.1. Whoops. Right at the end of that. Alright. So that is it for 6.3. 6.4 is not as long. It's just one method. I'll see you then.